Your skin is constant, right? It protects you against everything. Your nose filters, are they constant? Yeah, they don't change, right? You have things like saliva. Is that constant? Yes, it doesn't change. When you find these things in this system that are consistent, that's probably part of your innate system. They don't change. Now, when I talk about your other adaptive, those cells change. They change depending on what's in the system. These don't. So unbroken skin has to be there. Mucous membranes have to be there. They're going to help catch anything. Think about your trachea. It's lined with mucus to catch any debris that may get in, toxins. You see eyelids. They're covered here with lysozymes. They're going to help keep bacteria out. Microbiota, acid in your stomach. Right? Anything you swallow. I think of this as chewing on your pen. Right? All that bacteria then is swallowed down to your stomach and it's died. It's killed off by the acid inside the stomach. Low pH in your urinary tract, vaginal canal. Those low pHs also help to destroy bacteria as needed. These are all innate responses. Okay? None of them are specific. They're the same all the time. And that's why I think you should keep it separate. Now, these are cellular. On top of this slide, I would write cellular. These are a little bit different. These aren't barriers of any kind. They're cellular things. But here's the other problem, guys. These are still consistent. You always have them. They don't change depending on what's in your system. You're always going to have things like, in this case, in turtlefish, like antimicrobials. What do? They stop microbes. That's the whole idea. They're always there. If a microbe comes in, these guys are going to help kill them off. Natural killer cells, always present. Natural killer cells are sometimes your first responders that come in and they just kill stuff off that's not supposed to do. They just kind of, I think of them as like Pac-Man. Okay? They just kind of go around, just eating things that aren't supposed to be there. Okay? They're natural killer cells. We see here phagocytes, similarly speaking, these eat things up. The inflammation process, fever, all of these are non-specific. Okay? So when you talk about them, the whole objective is to recognize that they help you out and any time that you need them to. Now, when you look at phagocytes, there's two different types. Phagocytes, once again, are your eaters. In my mind, they go around and eat things up, take them in. You have two types, wandering and fixed. Wandering are free spirits. They go wherever they want. Wandering, go wherever they want. They travel in the blood. Okay? Fixed, though, they stay in one spot. Ball and chain. So wandering get to go through the bloodstream, they're free spirits. Wherever we want to do, we do. Now they're not specific, they're just going to be like Pac-Man and eat stuff up. They're just chilling. The fixed ones have to stay in one spot. Fixed macrophages stay in places like the spleen and the liver. Stuck here, cannot move. I must only be Pac-Man here. Okay. Natural killer cells I just mentioned, sometimes these are your first responders. I will tell you that natural killer cells are oftentimes cells that respond to tumor cells. So they are oftentimes related to cancerous things. We'll discuss those at the end of this chapter as well. So I put a tumor cell in there. They respond oftentimes to tumor cells because those are recognized as being non-U. Antimicrobials inhibit microbes. That's what they do. They stop microbes. So these microbes get into your system. Antimicrobials try to, what we would call, sequester nutrients from them. So they starve them, so to speak. They kill them off. Complement system is related to cell lysis, or the breakdown of a cell. Cell lysis is like the explosion of a cell. So complement system works with antibodies to cause cell lysis. Complement system works with antibodies to cause cell lysis. Two more things here. Iron binding proteins. Let me talk about those. They do what they say. Iron binding proteins take up iron. Now, why would they do that? They do that because bacteria need iron to replicate. Bacteria need iron to multiply. So these iron binding proteins that are inside of your system go around and take up iron. They do that so that bacteria can't replicate. Because if bacteria need iron to replicate and then now they're all taken up by these proteins, it's all good. Sorry, not today. Okay, so your body is helping you out there. It takes up iron because bacteria need iron to multiply. Lastly here, interferons. Interferons do something really important. They inhibit viral replication. interferons inhibit viral replication. And that means they stop viral replication. Here's how they work. If I am attacked by a virus, unfortunately, waving my white flag because I'm going down quick, okay, done, dying, and I want to save my friends and family, what I'm going to do if I'm infected by a virus is I'm going to begin to release interferons. And what these interferons do is they go out and they alert the system, hey, there's a virus in here that's trying to get you. Please be careful. And it also aids them in alerting the system and inhibiting the viral replication. So it's kind of an interesting thing in how they work. They're actually released from an infected cell, okay, that's been attacked by a virus in that case. Now, phagocytosis is where I will start next time because we have to talk about these steps.